Voice over LTE. So LTE was designed for data, and they ignored voice until some people said, no, you can't do without voice. Okay, so it was added in the later generations, later releases, and that is called VoLTE, voice over LTE, VoLTE or something. And so original LTE is not circuit switched, and the voice is circuit switched, at least in the rest of the network. And so one thing you can do is, and this is what they did when release 8, 9, 10, 11 came out, is that they just gave it to the previous generations. They gave the voice to previous generation. So if you have a LTE phone, you will need to have a 2G or 3G in that to handle voice. And so you cannot have a pure LTE device that can do voice as good as, those things, right? So that is called circuit switch fallback. Circuit switch fallback, CSFB, that means you need dual radios. You need 2G and 3G radios and everything else to handle just the voice. So now if you want to do VoIP is voice over IP kind of thing, that you can do on LTE. And so there is a new function, basically it's not a new function, there is a function called IP Multimedia System, IMS. Okay, so the data, again the data will go straight to the base station, but the control will go through IMS, and then the IMS handles the call setup signaling. So that is what control means. Call setup signaling means when you ring, it rings on the other side, and when you disconnect, it disconnects. All other functions which are related to setup, but your voice itself is the data. Right? That doesn't have to go through IMS, that goes straight through the serving gateway and packet gateway over there. So the voice goes, data goes like this, the control goes through all these boxes, and the boxes have their standard previous management, and I will remind them what they are. Policy, charging, rules and functions, we know what they are, they're just charging for the minutes. HSS combines two boxes, home subscriber server combines two boxes, the HLR, which was the home location registers, and the authentication center. In the previous case, we had an authentication center to make sure that you are you. So that those two things are combined in HSS. And MME is the basically mobility management, deciding which tower you should be connected to. So when you are moving from tower to tower to tower, MME decides which tower you should be connected to. So those are old functions. They have nothing to really to do much with the voice. And so real new function is IMS. Okay. Just like in the previous slide, we have one new box which was MCE. Now we have one new box which is IMS, which handles the control part. Okay. Now, in addition to this, there is something new in the physical layer itself. In the here, that transmission time interval allows to repeat the uplink transmissions in 4 consecutive subframes. So when you are speaking, they may allow you to speak 4 times the same thing. Basically, you speak once, but the phone will transmit it 4 times. Okay, just to make sure that the voice gets there. And I'm not sure, that doesn't make sense to me, but I don't know why it is so important that the voice gets there, because after all the data gets there, so the voice. But the thing in case of data is that can be retransmitted. Right? If it doesn't get there, if there's an error, you can retransmit it. For the voice, you cannot retransmit it. So you might as well transmit it 4 times right up front. Okay? And TTI, transmit time interval, is basically that subframe that we talked about, which was 1 millisecond long. Okay? So in each subframe, and actually 4 consecutive subframes, you transmit it here, and the next millisecond again, and next millisecond again, and next millisecond again. Okay? And that way it gets 4x power, it gets better link budget, and then the error rate goes down significantly. Basically by repetition, yeah.
How does it improve the link budget?
Yeah, so this basically what it means is, okay, So you receive the same signal 4 times, right? I mean, so the link loss is same, but your decoding capability is as if it was 6 dB better signal because you get 4 times. Okay, 4 is 6 dB by the way, right? So if your signal was 6 dB weaker, it will have the same error rate as, 6 dB, if your signal was 6 dB stronger and sent once, it will have the same error rate as this signal, which is weaker but sent 4 times. That's how it increases it improves the link budget. What it means is that you can sustain 6 dB more loss and still have the same error rate. Okay? Is that clear?
Yeah, but the data rate is too low.
And data rate is very low, so that's good. That helps. Data rate is low, so you can have some lower encoding and improve the data rate there too. All right, semi-persistent scheduling. So now the scheduling in LTE is every millisecond. Every frame we decide who is going to speak, or who is going to get the frames, right? In this case, it's semi-persistent. We might give you that, okay, every 20th frame or every 30th frame, 30 milliseconds actually, every 30th frame you will get to speak. Okay? So that way, you know beforehand when your turn is coming up and you are ready and you don't miss your deadlines. So this is semi-persistent because it is not forever. You might disconnect after 30 milliseconds, so then we want to make sure that we don't give you too much in advance. Right? So for few seconds you might get it. Packet bundling, and then if you want, you can. The packets in the voice are coming every 30 Okay, let's see. Every 30 milliseconds. No, let's see. I have to think about it for a minute. Okay, so we are doing 4K sampling. 30 milliseconds is for TV. For telephony, we do sampling 4,000 times a second, which is 25 millisecond, I think. 25 times, 4 would be 100. So just think about it, 4,000 times a second. Okay, it is 1/4 of a millisecond actually. Okay, so 250 microseconds you get the frame. And you may not want to send every frame as it is, right? So you might combine multiple packets. So that is called packet bundling. All of them will go together and will not make much difference. All right, so this is all I'm going to say about VoLTE. Voice over LTE is that they have a new function and 3 changes to the transmission. First change is DTI bundle, you repeat it 4 times. Second change is that you give them permission right in advance. And third change is that you just don't send on every time you get the frame, you just wait for some time. Scheduling, yeah, semi-persistent scheduling we discussed before.
Yes,
so we are using it for this one. So this was not a new thing. This was not a new thing. But this helps this is particularly used for this as well. That brings us to the end of LTE-Advanced. And 7 key things that we need to remember. First is LTE-Advanced meets and exceeds all requirements for 4G. Right? And 4G is specified in IMT-Advanced. Now, again to remind you, the IMT comes from ITU. And 4G comes from which organization?
3G.
Sorry, LTE-Advanced comes from 3GPP. Right? They are 2 different organizations. 3GPP is basically a business organization, and ITU is mostly a government organization. Government makes the rules, business people follow, although they are the same people generally. Because let's say United States, who would be in ITU? Same guys, and AT&T, Verizon, and so on and so forth. They go together under the government of the United States team, and they make the rule there. And then they go to 3GPP as individuals, companies, and then discuss about how to implement those rules. All right, so that is that. Now, three key factors that affect data rate are spectrum, spectral efficiency, and cell size. Now, this is one thing, there is no magic anywhere. When you want to get a higher data rate, in all the technologies that we have discussed, there are only three ways. Either you get more spectrum, and which is what we did in AC and everything else, is that we kept getting from 20 to 40 to 60 to 80 to 160, and here same thing. Second thing is spectral efficiency, how you code them. That is where most of the magic comes in. And then the cell size, you reduce the area. Okay. An LTE can aggregate up to 5 carriers to make up to 100 megahertz. So they can aggregate up to 5 carriers, and obviously they have to be 20 megahertz each. And they can aggregate less than 20 megahertz too, but then you won't make up to 500 megahertz, right? To get 100 megahertz, you will need 20 megahertz times 5. LTEA has frequency reuse factor of 1. So they are going to use the same frequency everywhere. That's why they have all these interference, cancellation, talking, and everything else that we saw, ECOMP, COMP, ECIC, and so on and so forth. So everybody tells everybody else, look, I'm using the same frequency as you are using. So let's coordinate, right? Frequency reuse of 1 means same frequency is used everywhere. And they use high order MIMO to get better spectral efficiency. LTEA relays nodes to cover remote areas and hot spots, and therefore it allows femtocells as well. Okay? And it allows picocells, and it allows microcells, and so on and so forth. Basically, that is called HETNet. Heterogeneous network. Codebook and non-codebook pre-coding improves the MIMO. And so we saw as to how they use the codebook and pre-coding to randomize the signal, and that improves the signal reception. Then coordinated multi-point operations, COMP, allows mitigation of interference at cell edge. And COMP can also be used with cross-carrier scheduling, which was the last slide we did last time, is that you might have 5 carriers, but you might schedule on one for the second carrier, third carrier, fourth carrier. That is called cross-carrier scheduling. Okay? Now, any questions about anything? Yeah.
This one is slide number 20.
This is the cross-carrier scheduling, yeah.
I couldn't understand the concept of mapping.
The concept of mapping.
Yes, the red one.
Yeah, right. So, last time somebody had asked the question. So the question is, what is the red area map? Basically, in both WiMAX, in all three, WiMAX, LTE, and LTE-Advanced, every downlink frame, when it starts, it has a map of the rest of the frame. A map means it just tells you that the byte is starting from that carrier to that time and all that rectangle belongs to user 1. The other rectangle and the rectangle size will be specified belongs to user 2, and it will also specify that user 2 we are using 64 QAM for you. So the coding, everything is specified in the map. Okay? And so everybody has to listen to the map. It's like somebody asks question whether it is beacon or not. So it is really a beacon in some sense, but in the beacon, so much detail is not there. I think the beacon simply mostly does is the time, and then it says whose packets I have stored, right? But here it is more than beacon because it tells you currently in this frame where the bits are for whom. And same thing, the downlink map will also contain the uplink map. The downlink frame will contain the uplink map. What it says is that in the uplink frame that is coming up, user 1 can transmit in this rectangle, user 2 can transmit in this rectangle. So both the maps are in this downlink frame. Right? These are called maps. DL map and UL map. Yeah.
So these words are the PDCCH?
Okay. PDCCH is a control channel. And now, I mean, I have to just verify this thing that the PDCCH is the entire map. Maybe the map has more than PDCCH. It may have other control channels. Okay, So I have to just go and look at all the control channels. Whatever control channels are there, they will all be in the map. So the map is actually, okay, I can say right now without even checking, that the map is actually more than the control channel, because some part of it is control channel and some part of it just general announcement about the cell. So map is like the header. Now the header does not have to be the complete control channel. Some of it can be, for your information, other things. So PDCCH is one of the control channel, downlink control channel. Actually, right there it doesn't include the uplink. So PDCCH is the downlink control channel, which is part of the map. There are lots of books on LTE-Advanced. Lots of books, dozens of books. However, since we are not buying books here, so I just put these PDFs which are available for download. And then there are books, which obviously some of them are Safari too, and actually all of them are Safari here. So there is no shortage of books. Okay. Similarly on small cells, and then there are lots of specifications. Now you won't really need to read these specifications at all, but I just try to keep them together so that when I read it, I do read some of these specifications, by the way. So when you are going to work in this area, you probably will need to read them and you will need to find where they are, right? But right now you can just do with the articles that I have mentioned, and that should be sufficient.